To continue with the large intestine. So after the ileum empties into the large intestine through the ileocecal valve, um, it enters the large intestine. What is the contents of the small intestine by this point have had most of the things that we want absorbed, and the remainder is a watery mixture of that which we want to get rid of. It's too expensive to the body to lose all that water, though, and so we'll see what the large intestine does momentarily. Now, the large intestine is exactly that. It's large. And there's some unique features to it. One of the things is that the muscularis really is mostly circular, and there's only three bands of longitudinal smooth muscle. And these are called the tenicola. And because of this arrangement, the large intestine is kind of pleated, or it's almost like smocking. By drawing the string, you create these kind of puffs, and these are called the haustra. And so the haustra are pockets like sacs caused by the tightness of the tenicola. It's much like a curtain being pulled across. And then on top of that, there are these drips that look like candle wax of fat-filled things. And these are called the epiploic appendages. Nobody really knows what they're for, except to store fat. It's divided into regions. The beginning, the blind-ended pouch, where the appendix is found, is called the cecum. Then the vast majority of it is called the colon, and it's subdivided into regions. Then there's the rectum, and then there's the anal canal. So that it's like this. The ileum is here, the ileocecal valve is here. This is the cecum, this is the ascending colon, this is the transverse colon, this is the descending colon, this is the sigmoid colon, the rectum, the anal canal. The difference between the rectum and the anal canal is that the anal canal is not it's in the floor of the pelvic cavity. This is within the cavity. The appendix sticks off here. It's called the vermiform appendix because it looks like a worm. This is the tenicola. These are the epiploic appendages. These are the haustra. This bend between the ascending colon and the transverse colon is called the hepatic flexure. And the bend here between the transverse and the descending is called the splenic flexure, because this one happens behind the liver, this one happens by the spleen. The mesentery that holds it is called the mesocolon here, right? And that's about it, really. Now, this runs up the right side of your body, across, down the left side of your body, and this brings it back to the middle. It's sigmoid, which means it looks like the letter sigma, or S-shaped, is there, so there's can be some slack so that when you rotate your body, it doesn't tension too much. The ascending and the descending colon are actually found retroperitoneally. They don't move very much. They're attached to the body wall. Transversely, it is anchored by mesocolons. So the sigmoid is kind of half the transverse colon, as it were. So it ends up looking like that. If we look at everything in the abdomen kind of together, we can see all of the serous membrane. So the green is the parietal peritoneum. So we can start kind of here, parietal peritoneum. Then we've got a visceral peritoneum over the liver, which then becomes the lesser omentum, then a visceral peritoneum around the stomach, then the greater omentum here, and then the mesocolon here. So that's kind of one pouch, as it were. The other pouch is this. This is the parietal peritoneum, visceral peritoneum over the liver, the other side of the lesser omentum, visceral peritoneum over the stomach, the other side of the greater omentum, the visceral peritoneum over the transverse colon, the other side of the mesocolon, parietal peritoneum that goes over top of the duodenum, then mesentery, visceral peritoneum over each part of the small intestine, mesentery and small intestine, visceral peritoneum, or parietal peritoneum rather, coming down here, over top of the bladder, which is retroperitoneal, and then back up to the beginning. So that in the abdomen, there's really two cavities, here and there. So the rectum and anus are different than the rest of the colon. The rectum, which means straight up and down, has got little valves so that you can pass gas without passing feces. The anal canal is in the floor of the abdominal cavity. And then the sphincters are what keep it closed. There's two sphincters. There's an internal anal sphincter made of smooth muscle that's involuntary, and an external anal sphincter, which is skeletal muscle, which is voluntary. The internal anal sphincter is the one that relaxes when you feel the need to defecate, and you use the external anal sphincter voluntarily, using quite a bit of ATP, until you can get to an appropriate place to defecate. It looks like this. You'll notice that there's a valve here, keeps feces in place while it lets gas part. There are anal columns so that the anus here can expand like an accordion. There are veins here that are called the hemorrhoid veins, and when they become varicose, that's when you have hemorrhoids, internal and external hemorrhoids. You can see that there's an external anal sphincter here and the internal anal sphincter here. This is called the pectinate line. It's basically the place where it's closed. So, what of the mucosa? It's a simple columnar epithelium until we get down into the anal canal, where it changes to a stratified squamous. By the time we get to the anal canal, there's much more chance of friction, much more chance um, of abrasion. So you need a stratified squamous epithelium. Not keratinized, but stratified at least. There's lots of goblet cells. There's along the whole large intestine, making a lot of mucus, again, to keep everything fairly slippery. It's colonized by flora, which really is bacteria. Now, what the flora does for us is they synthesize the B vitamins and the K vitamins. So they basically eat the things that we can't, and they pay their rent in the form of vitamins. So it's important to the body, and they must therefore be absorbed there. Now, the other thing that they do is they'll ferment any indigestible carbohydrates, things like cellulose, which we can't digest. And again, that's what they live on. And in some people that are missing the brush border enzymes, so they will do lactose and things like that. The byproduct of their cellular respiration are gases and various acids like lactic acid and things like that. The gases tend to be methane, simple carbon, like CH4. And we all know how we release that stuff. You want a proper colony of bacterial flora to maintain health. When certain bacteria start to predominate, then you can end up with some pretty serious health things like Clostridium difficile, which is a big problem in the hospitals right now. It's really bacterial flora. So what happens in the large intestine? Obviously, the vitamins are synthesized by the flora and then absorbed. But the last reabsorption of water happens here, and the last reabsorption of some electrolytes. It's by no means the major source of water reabsorption. Most of that happens in the small intestine. Just a small remainder is absorbed in the large intestine. So really, the major function is to produce feces. To produce feces, move them towards the anus, and get rid of them. Now, how does that happen? Most of the day, it happens with segmenting movements. So little sequential contractions move things along and squeeze things and allow lots of time to reabsorb any remaining water, etc., etc. But there's another movement that happens, right, called a mass movement. And it's a very slow, very strong peristaltic movement. And it happens because of food in the stomach. So when you have something to eat, the enteroendocrine cells release hormones, the splanchnic nerves fire, and the presence of food in the stomach initiates this reflex that causes this big peristalsis that moves down the entire colon and pushes any feces that are there into the sigmoid colon and the anal canal. This is why after you feed your dog, you should take him for a walk. This is why after your morning coffee, you have to visit the bathroom. It's triggered by presence of and stimulation of the stomach. So when the feces are in the rectum, it distends the rectum, the anal canal, which then initiates a reflex. It's done through the parasympathetic system. The internal anal sphincter relaxes, right? And then you tighten the external anal sphincter until you feel comfortable, until you've made it to a bathroom or wherever you're going to defecate. And then you consciously relax the external anal sphincter and defecation proceeds. So there's sensory nerves, and there's motor nerves that are involved in it.